Hi, I'm John Villalovos, Senior Applications Engineer with RKI Instruments, and welcome to our channel. Today, I want to show you our AC2 Surface Analyzer, and basically this system analyzes different materials, such as organic materials, semiconductor materials, or metals, for work functions and ionization potentials. Very effective for research scientists that are looking to make the most efficient materials available for today's photovoltaic industry. Basically, the AC2 system consists of two modules. We have a light console and a detector console, and they are interfaced with a fiber optics cable. To the right, we have a computer system which basically houses the computer program. This can be either a laptop or desktop system. I'd like to point your attention to a couple of components that the AC2 requires. One is compressed air. Here I have a portable compressor that basically is supplying compressed air. That keeps the sample path nice and dry, free of moisture, and under a slight positive pressure. The other components here are power transformers. One is for this air compressor, and the other one is for the AC2 itself. The AC2, as well as this particular portable air compressor, requires 100 VAC. So obviously they're converting North American 115 VAC to the required 100 VAC. Next, we're going to turn the AC2 system on. Before I do that, I want to direct your attention to the computer. We have the computer program open already, which is the first step to do, and we'll cover that program in much more detail later. For now, a few more comments about the consoles. On the light console, we have a couple of status lights. Basically, power, steady on, and standby or warm-up mode is flashing. We have a red trouble indicator. Should the system ever encounter a trouble condition, that will illuminate as well. On the detector console, we have the same lights for power, standby, trouble, and in addition, an open light, which illuminates whenever the sample door is open. And now turning the system on, I'll turn on the power button here. We can hear the system making some noises as it's initializing. We can see that the lights are flashing, which is normal. The trouble light will flash for several seconds until the system stabilizes. Then that light will extinguish, and just the power standby lights will be flashing green. And that state will be maintained for about 30 minutes. We have to let the system warm up for about half an hour before we can proceed. And now we'll take a look at the AC2 software, which I'll start by clicking on the AC2 icon. Opening up the program. Okay, and this is what the home screen, so to speak, looks like. We have data files to the left, basically by date. It goes by year, day, and month. And then we have some data files over here in this upper right quadrant or part of the screen. What we need to do is create a folder for today's activity. So that's going to be create folder. Okay, and I'll just put in today's date, which will be 16/09/02. Press enter to register that. And then when I click on this folder, it will clear the data screen because obviously we haven't run any data for the day. The next thing I'm going to do is confirm a connection. I've already warmed the AC2 up for about half an hour, and now it's ready to go. But we just want to do a quick connection. It's already been done. Okay, great. Just verify that, acknowledge it. And now we're ready to open up the work function screen, which is the screen that will allow us to put our parameters in to run a sample for the AC2. We have a vertical and horizontal axis. We have a photon yield squared over here on the vertical axis, and our electron volts on the horizontal axis. So that is 4.2. Right now it's set up for 4.20 EV up to 6.10 EV. The range of the unit is actually a low of 3.40 EV up to 6.20 EV. So basically you can scale this EV adjustment to more closely encompass the area around your anticipated work function. So therefore, you're not sampling a lot of EV values that you know is going to be ground level, nowhere near the work function. That just takes more time, so you can shorten up that scale, which will produce a faster runtime. But for the moment, we're just looking at 4.2 to 6.10 EV. Next thing I'm going to do is to name the sample, and that's going to be a gold test sample today. So AU underscore, and then today's date again, 160902. Press enter, and that basically is just signifying that we are doing a gold sample on today's date. I want to run a gold sample to make sure that the AC2 is performing properly before I actually run different material samples for a customer. Okay, and again, the scale is correct. Basically on this column here, you want everything to be in green highlights. That's green to go, red for stop, so we have to change this one down here. Start energy, finish energy, the step of electron volts are in 0.10 EV steps. The counting rate is 10 seconds per data point. And then right now the target UV intensity is 10 and my actual UV intensity is 0. So I want to bring this down just a little bit. We see an old data from about a week ago or so. So I want to clear that out. So right click and then adjustment data delete. That's cleared that out. Okay, so now I'm going to set the target of UV intensity, and that'll be in nanowatts. Gold requires about 10 nanowatts to get a good slope of data, and you'll see what I mean when I run that. Okay, so basically I want to put in 10. It did say 10, but I'm just going to type it in anyway just so you see the function. Okay, and at this point I want to come over to the measurement M little title here, and then go to measurement UV intensity adjustment. We want to correct that to 10 from 0, and right now it says set the UV intensity at 10 nanowatts. Yes. Now we're going to hear the machine make some noises, and it'll make that adjustment and actually make the UV intensity 10 in our red bar here, which will turn to green when it is either set to 10 or very, very close to 10. It might be 9.9, but it's going to be a value very close. So we'll just take a few moments to let the machine make that adjustment. Okay, the adjustment is done. As we can see, it wants to be acknowledged. UV intensity adjustment done. Okay, and now it did appear in the green bar at 9.9 nanowatts, which is close enough to be valid. Okay, so now we can actually run our test sample. I'm going to go back to measurement M, and then click this time sample S, and that is going to move the sample tray. Okay, at this point we can load our sample into the AC2. Now we'll put a sample into the AC2 detector console. I'll just push the door down, it kind of rebounds upward, exposing the sample tray. On the sample tray, we can see crosshair markings at which the intersection is where the beam from the light source actually imparts itself on the sample. It's a 4 by 4 millimeter footprint, and that is where it's going to contact the sample. In addition, we have two small clips here which serve as holding clips, which will hold the sample down, as well as grounding clips, which will ground the sample, freeing it of any static electricity or discharging any static charge that the sample might have. So I'm going to move these clips out of the way just for the moment, and that will expose the area where I'm going to place the sample initially. I have a gold reference sample, which is something that we use to test the AC2 before we run any actual samples for a customer. Basically, we want to make sure the AC2 is operating properly, and the gold reference is a known quantity where we know what the work function range is likely to be, and therefore we know if we're getting valid readings or not. There's a little adjustment wheel underneath this sample tray, which I'm going to move, and you can actually see the tray being lowered. This is a height gauge. We want to establish the correct height from the top of the sample to the bottom of the detector, which is very small. We want as small a space as we can achieve. So basically I'm going to raise the sample tray back up. There is a height gauge pin with a retractable pin. I'm going to go slowly until I just make contact with that pin. It's retracting into its holder. Then I'm going to back off again just a little bit, going downward, exposing just a little bit of a gap that I can see. The way you can test that is to release the height pin gauge and then move it back over the sample. And if you can move it over the sample without moving the sample, then obviously you're not touching the sample, and that's sufficient height, a very small gap. And now I'll move the sample to the center of the tray, basically just putting the middle of the sample at the crosshair intersection. Okay, it doesn't have to be perfect, and we're just going to hold it down with these clips, which will hold the sample down and ground it as well, getting rid of any static discharge, as I had mentioned. And now we're ready to actually run the sample through the program sequence. Okay, so now we put the sample into the unit. I'm going to acknowledge the return of the sample stage, and you'll hear this time the sample stage is being moved deeper into the unit underneath the detector. And now we're ready to run the sample. So go back up to measurement M, and this time we're going to click on measurement G, and then the data points will start to plot on the screen, and then roughly once they've started, then you'll see a new data point appear every 10 seconds. Okay, so now we see that the sample has been done for the test gold sample. So I'm just going to acknowledge that. And right now, measurement done. Save this data. Yes. It looks like a good slope. Basically, in a nutshell, we can see the raw data here. We've got our ground level and then what we call a regression line. And what we're looking for is linearity. It doesn't have to be a perfect 45-degree slope, but we want a good approximation of linearity. Then we know we've got some valid data. If I did not have the nanowattage intense enough on my UV source, then this slope would be much more shallow. It might be just above or perhaps not even above the ground level at all. Then I would know I need to turn it up. If my UV intensity is too strong, then this slope is going to come way sharply up like this. It actually might even be nonlinear. So if it comes up like so and goes straight up at some point, then I know it's too strong. I have to turn it down. So 10 nanowatts appears to be a good setting for gold here. So everything is valid. I've saved this data, the raw data. At this point, I need to run a light correction coefficient procedure, which we'll now see. We start that by closing this file, closing the screen, and then I'm going to click on the folder again. That pulls up the gold sample that was just run right here. You can see that. And then now I'm going to do a light correction coefficient. Go back up to measurement M, and then go down to quantity of light correction coefficient. Click on that. That brings up that screen. I just basically want to type in the sample that I did right now, which is the gold sample, AU_160902. Okay, and verify that my start and finish energy is consistent with this procedure as it was with the original sample run. Everything is consistent. We can see all that right here. All the numbers are there. And then I'm going to go back to measurement M and do a measurement G. So now we'll run a light correction coefficient. So we'll give the unit a few minutes to run that. Okay, so now the measurement has been done for the correction. Save this data, yes. Okay, so we've done that. And we're going to close this file. And go back here and click on the folder. And now the quantity of light correction has got a little light bulb for light. And that's how you can always tell that from the sample data, which is a graph icon. And what we need to do is basically just paste this data over the raw data. So I'm going to do that by just clicking and then dragging over and releasing that. So that should have done that, impose the light correction data on top of the raw sample data. Okay, so now I'm just going to click that again and come up here, and now I'm going to click on the data file. There we go. Okay, you can see that now the quantity of correction has been imposed in here. It's got a title, whereas previously it did not. So that's how I can tell that it did accept it. So at this point, we can now plot the ground level and the work function. All right, so basically I'm going to do select what I consider to be the data points for the ground level, which will be right here. Okay, ground level, there we go. And usually your first 1 or 2 data points are transition points, so we don't necessarily want to include that. But this is a pretty reasonably linear slope, so I'm going to include at least these points here. Okay, right click, that brings up this little subtable or list, and then just left click regression line, and there is our regression line. So we can see that we have arrived at a work function for today for this gold sample under today's temperature and humidity conditions of 5.01 EV. And all it needs to be done now is to save this data to an Excel spreadsheet. So I've got that. I'll just click on my Excel icon there, open that up. Okay, and go back to the AC2. I'm just going to put my arrow in this area, general area. Click it there, and now Control C, enter. Control V, enter. Okay, I'll just set up the next point. I typically put it right in here. Go back to the AC2 window, put this cursor in this area of the screen, click, Control C, enter, Control V, enter, okay, and just right next to it, we're going to put our last bit of data, and that's going to be down here where the blue is. Put our cursor there, click it in there, Control C, enter, Control V, enter. Okay. And then I could save it right now. I'll just expand the columns here just a little bit so we can see more accurately as to how the formatting is going to be once you print it out or look at it later on. Okay. So basically, this is how your data is going to look when you print it. I need to click on this one here. There we go. And B. There we go. Okay. Now you can read everything. Okay, now I'll save this. Local disk C. I'm just going to put in the AU sample again, today's date. Okay. And there we go. Just close this out. And we're back to our screen, AC2 screen. Now I'm going to close this file, or close the screen, I should say. Close the screen. Okay, we're back to our home screen. And now I'm going to go to measurement M, and then bring up the work function screen, and then go to measurement M, and then sample S. That will retrieve the sample stage and bring it out to the access area where we can remove our test sample and then put in a regular sample of some other material if we wished. Move sample stage ready? Yes. Okay, so now the sample stage is returned to the front of the unit. At this point, I can retrieve the sample, put in a new sample if I want to continue running samples, and continue with the process. So what we've seen today is how easy and quick it is to run a sample on the AC2 Service Analyzer. We started off by booting up the computer program. We then turned the system on, put a sample into the sample tray, and then run that sample, arriving at a work function. We then save that data to a computer. In the future, we'll have a much more detailed program explaining the function of the software. Until then, thank you for watching our channel.